My name is Dan McEwen, and I go to school here at Lake Area Tech in robotics. And we had to make a final project for the end of our second year. And for my final project, we decided to make a sensor keyboard, which we nicknamed SAMI, Sensor Activated Musical Instrument. It consists of 13 microcontrollers, 13 sensors, 13 relays, and 4 speakers. And what we were trying to go for was a musical instrument that you could play by just waving your hands over it. And we had a bunch of sensors in the back, we hooked everything up, and it turned out to be a really good, fun project. And I'll take you the tour of what we have going on right now. Right here is our microcontrollers, each one hooked up to a sensor, or up to a relay. And each relay is connected to the sensor. And what happens when the sensor is tripped, these are motion sensors, when the sensor is tripped, it closes the circuit, sends a signal to the relay, which closes the relay. And when the relay is closed, it allows the signal from the microcontroller to pass through the amplifiers to our speakers. And that's basically the gist of how this keyboard works. The basic brain of the SAMI is contained right here with the Parallax BASIC Stamp microcontrollers. There's 13 controllers in all, and each microcontroller generates its own frequency, which is each note you hear. From the microcontroller, the frequency is passed through the relay, and when the relay closes, it lets the frequency pass through there to the speakers. Each relay is tripped by the sensor, and when your hand is waved over the optical sensor, it activates the relay, which closes and allows the signal to pass to the speakers. The overall cost of this project was around $2,900, but a lot of that cost could be cut down. We had some problems with our microcontrollers only being able to produce one frequency, which is why we had to use 13 to produce the 13 different notes we had. But that problem can be fixed with one chip that they make for these that can allow you to do multiple outputs from one controller. And that will cut your cost down by at least $600. Another thing that we had problems with was powering everything. And that can all be simplified by one power supply, but we still have different power sources coming to power. After the microcontrollers, we fixed that problem. Next, we had to produce the sound, and we needed speakers to do that, to carry the frequency to the speakers, which would make the sound. But the problem with that was that the signal wasn't loud enough to be heard through the speakers clearly. So to conquer that problem, we made an amplifier using a 386 op amp. And the circuit we designed produces a gain of 200. So the signal comes in as amplified 200 times to come out of the speaker, which gives you the loud sound you hear. And each circuit, there's 3 amplifying circuits that send 3 different signals to the 3 speakers we have. And each circuit can be controlled by a 10K potentiometer, which adjusts our volume and adjusts for distortion.